So here we are at Heat and Matter, Part 2. We'll pick up where we left off, looking at convection. So when we were talking about convection, convection is heat transfer by moving fluid. Okay, so heat transfer by moving fluid, and we've got multiple examples here: a space heater, gas furnace, and then I mentioned earlier that wind on Earth is caused by unequal heating, so that's convection. So we have in a diagram here with a heater. Heater heats up warm air, heats up air. Warm air rises, it cools off, it drops down, and cool air it takes its place, it heats up and it rises, and so you end up with this moving fluid, which is a gas. And that's convection. The third way that heat can move from one thing to another is by radiation. Now, radiant energy is associated with electromagnetic waves. So this is when heat is transferred directly from one source to something else by electromagnetic radiation. It's not because of wind, it's not because of direct contact, but because of electromagnetic radiation. So if we were standing in a greenhouse, or if you're sitting next to a window that's being hit by the sun, there's no wind, so you're not being heated by a moving gas, but you're being heated because of the radiant energy from the sun itself. So that's radiative heating. This can operate through a vacuum, which is the only one that can. The Earth itself gets heat from the sun. The whole Earth gets heat from the sun through radiation. Okay, radiative heating, because there's a vacuum, or a near vacuum anyway, between the sun and Earth. There's not a direct contact between us. So every object emits and absorbs radiation, and so temperature determines how much radiation something is emitting and what kind of light it gives off as a result. So as something is hotter, the hotter something is, it's going to give off a different wavelength of light. And so we can actually measure, those two things are closely related to each other, and so we can measure how hot something is by looking at the wavelength of light that it's given off. This is how we can make determinations about how hot certain stars are, by measuring the wavelength of the light that's being given off by the star. We can determine how hot or how cold that star is. Now, this is also causing global warming, because the amount of heat energy that we're taking in isn't changing. However, we are trapping a lot of that heat in with greenhouse gases, and so we end up hotter than we should be. And to some extent, that's a normal thing. Without some greenhouse effect on Earth, Earth would be too cold to support life. But runaway greenhouse effect is something entirely different. So here are some study websites, and of course your GACE information for middle grades and elementary. And with that, we almost made it through a whole lecture without the program crashing, and so we'll have a very small part 2. So that brings Heat and Matter to a close.